Okay, this is going to be a kind of quick video on the introduction to functions, or what can be called the language of functions. And so things we're going to look at is we're going to look at how to evaluate them and how to graph them, and then an application problem with them, which is essentially putting it all together. So first, when we talk about a function, we are talking about a relationship between your variables. So this relationship that we're talking about is going to be between your x and y, and we like to call that between dependent and independent. Okay? An independent variable is generally the x variable, but the way I like to remember it is the one who's essentially making all of the decisions. We call that the input value. It's also the value that gives you your domain. The dependent variable, which is usually your y, is the variable that has to, quote, follow all the decisions or rules. Okay? So we call that the output value, which usually gives you the range. Now when we talk about functions, we are talking about equations, where instead of saying y equals, we use the term f of x, which is this special notation here. And so this notation here just allows us to rewrite our equations in a way that allows for a more uniformed method of solving. Okay? So what f of x actually stands for is it says to input whatever this value is in the parentheses into whatever equation you have. So in looking at that, I have that we need to find f of -5 for the equation, or the function, f of x equals -2x cubed minus 7x squared minus x plus 12. So essentially what we're doing here is we are going to solve f of -5, where anywhere I have an x value, I'm going to substitute -5. So in other words, I'm going to substitute it into this one, I'm going to substitute it into this one, and I'm going to substitute it into this one. And so here, this becomes -2 times my something cubed minus 7 times my something squared minus my something plus 12. What is that something? Well, that something is this, which is -5. So anywhere that you have your parentheses, we are inputting -5, and now we are just simply going to simplify. So if we start down, my first term here is going to be a -2 times, and then I have -5 cubed. So that's the same as -5 times -5 times -5, which is going to give you a -125. Then I have minus a negative. So minus a negative, well, before you get to that, you need to realize this one is squared. So the squared is going to be applied only down into your parentheses. We're going to ignore the 7. So it becomes a negative. And then I have -5 squared, which is the same as -5 times -5. Gives you 25 as a result. And then I have negative of a -5, and notice if you look, there's no power up here, because this is essentially to the power of 1, which means nothing's going to happen inside the parentheses. So negative and negative gives you a positive. 5 comes out, and then I have a plus 12. I need to continue to simplify. We're going to come back to the beginning. I have negative times negative is positive, and 2 times 125 is 250. I have negative times positive is negative. 7 times 25 is 175. And then I have plus 5 plus 12. So if you look at that, 5 plus 12 is plus 17. So then I have 250 minus 175 plus 17 gives you 92 as a result. So there's a little thing to keep in mind, is that if you evaluate by a number, then a number will be your solution. Okay. Well, on the flip side, then, that means that if you evaluate by an expression, then an expression will be your solution. So the type of evaluation that you do is going to dictate the type of solution that you end up getting. Now, this is just one such way that we can set up an evaluation. Another such way is we can set up an evaluation in table form. So here I have that you need to complete the table for the following function, and I have f of x equals my 1/2 x plus 3. Okay. And so here I can see got a little typo going on. So let's go ahead and change this to match what's in the table. So we're going to have f of x equals my 1/2 x plus 2. Okay. So here, in order to fill in the table, I have my x values that I have chosen. So you need to remember these are the values that you choose because this is your independent variable. Okay. It means your y values over here are the ones that you have to solve for. So in order to solve for them, says that anywhere you have an x, you need to input your x value. So this is my 1/2 times my something plus 2. And I need to figure out what that equals. Well, what goes in here is that -2, because that is what I'm plugging in. So I have 1/2 times -2, okay, is going to give you a -1 plus 2. -1 plus 2 is going to give you 1 as a result. So essentially, to fill in the table, what you're doing is you are doing the math work here in the middle, and then you're writing your solution on the other side. And what this is doing is it would set you up to be able to use coordinate points, which sets you up for graphing, which, as you can see, is coming next. Okay? But in the meantime, we need to finish our table. So here, this is going to become the 1/2, again, times my stuff, plus 2. Well, 1/2 times -1, because that is what the x value is. So 1/2 times -1 is a -1/2 plus 2. So we get -1/2 plus 2. And this is going to give you 3/2 as a result. Okay. Or 1.5. So you can see it's going to be the same. So this becomes 1/2 times my 0 plus 2. So this is going to be the same as 0 plus 2, which is 2. Then I have my 1/2 times 1 plus 2. So here, this is my 1/2 plus 2, which is going to give me 5/2, which is the same as 2.5. And then I have 1/2 times 2 plus 2. 1/2 times 2 gives me 1 plus 2, which gives me 3. And thus, you have completely filled in your table, which at this point is all that we were asked to do. Okay. Now, like I said, that leads us into being able to graph. And so in order to graph the functions, the easiest thing to do is to create that XY table. And we're going to use our function in order to figure out what that table should be. So here we have 4x minus 1. So we're going to set up the table x, and then I have y is equal to my 4x minus 1. So I'm going to set this up, and then I'm going to go ahead and use the values from -2 to 2. That's going to give you this really nice snapshot right here around the center of your graph, which is going to tell you a lot of what it is that you are doing. So I'm going to do -2 to -1, 0, 1, and 2. Again, you need to remember the x values are the ones that you choose. The y side is the one that you are solving for. And in this point, we're going to get our coordinate points, which is going to lead to our graph. Okay? So I have 4 times my -2 minus 1. 4 times -2 is -8, minus 1 gives you a -9. Now, one thing that I've seen help a lot of students as you work through is once you figure out what your pair is, you write it as your coordinate point. So this is the point -2, -9, because this is going to help you when you go to graph. Okay? So now I have to do 4 times my -1 minus 1. So again, I have 4 times -1 is a -4, minus 1 is a -5, which is going to give me the coordinate point -1, -5. Again, now we have 4 times my 0 minus 1. 4 times 0 is 0, minus 1 is -1. So this is the coordinate point 0, -1. Then I've got 4 times 1 minus 1. So 4 times 1 is 3. Or sorry, 4 times 1 is 4, minus 1 is 3. So thus we have the point 1, 3. And then we have 4 times 2 minus 1. So 4 times 2 is 8, minus 1 is 7. Gives us a final point of 2, 7. Okay. So now what we need to do is we need to graph these points. So I'm going to come into my graph here. I'm going to start with my top point and I'm going to work my way down. So I have the point 2, -1. So that means, or sorry, -2, -9. So I'm going to go over 2 and then I'm going to go down 9. So over 2 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point is right here at the very bottom. The next point I have is -1, -5. So I'm going to go over 1 and 1, 2, 3, 4, 5. So that's right here. I have the point 0, -1. So that's over 0 but down -1. I have the point 1, 3, so it's over 1 in the positive direction, and then 1, 2, 3. And then I have the point 2, 7, so I'm 1, 2 over, and 1, 2, 3, 4, 5, 6, 7 up. And then I have to go ahead and connect my dots, and what you should notice here is that this one is linear. So I'm going to go ahead and use my ruler just to make it clear, but of course, depending on your teacher or what it is you're doing, you just need to connect your dots and make it as close as you can. But what you can see here is that this is actually linear. And that should make sense, because if you look at your equation, notice your x value here does not have anything in its exponent, which tells you that this was a linear graph. Okay. Alright, let's do one more graph example here. Again, we're going to make that xy table. So x, and then in this case my y is a negative x squared plus x minus 4. And this one is quadratic. So right off the bat, you should be able to tell a couple of things about this graph. First, quadratic means that your graph should be parabola. Second, a parabola means you're going to have that U shape, and your sign right here is going to tell you the direction. So here, because my sign is negative, it means my parabola should point in a downward direction. Okay, so that's kind of a few things that that equation tells you right off the bat before you even get going. Again, I would go ahead and use your points of -2, -1, 0, 1, and 2. And what you're looking for is you are looking for the change in direction. So you are actually looking for this point right here. Okay, so you're looking for the change in direction. Meaning when you're setting up your data table, you're looking for where your points say either continually go in a decreasing line and then all of a sudden start increasing, or vice versa, that they start out by increasing and then all of a sudden they change and they start coming back down. So that is what you're looking for, and as soon as you find that, you have enough points to be able to graph your parabola. So let's see if these 5 points are going to give me what we're looking for and allow us to graph that parabola without any problems. So we got to plug that -2 in. So this becomes the negative of my -2 squared plus a -2 minus 4. So -2 squared is 4. Apply the negative is -4. Positive times negative is negative, so I have a -4 minus 2 minus 4 gives you a -10. And again, you could write your coordinate points. So we have the point -2, -10. Okay. Now I need to plug in my -1. So again, this is going to be negative of my -1 squared plus a -1 minus 4. So -1 squared is 1. Apply your negative is a -1. And then I have -1 minus 4 is going to give you -6. So notice my y values are actually increasing in value. If you think about that negative, if you think about your negative line here, your negative values increase as they get closer to 0, and then they continue to increase as we go up. And so here we are in a increasing trajectory, which means my parabola is going the right direction. Now we need to look at 0. So I have negative of 0 squared plus 0 minus 4 is going to give me -4 as a result. 0 squared is 0. Apply the negative is still 0. Plus 0 minus 4. Okay. Now we've got 2 more. So I have negative of my 1 squared plus 1 minus 4. Okay. So here 1 squared is 1. Apply the negative is -1. So -1 plus 1 is 0 minus 4 is -4. And now I have negative of my 2 squared plus 2 minus 4. So right here, 2 squared is 4. Apply the negative is negative 4. Negative 4 plus 2 is a negative 2 minus 4 is a negative 6. So what you need to look at is you need to look that right here we actually have that change in direction. So what you can see here is that my y coordinates are steadily increasing, and then right here all of a sudden they start decreasing again. And so between these 2 points, which means we're looking at about x being 1/2, we have our change in direction. So we're going to go ahead and graph these points, and you're going to see how this works. So I have the point -2, -10. I then have the point -1, -6. I've got the point 0, -4. I have the point 1, -4. And then I have the point 2, -6. So let's go ahead and see where those points lie. -2, -10, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is down here at the bottom. Then I have the point -1, -6, so over 1, 1, 2, 3, 4, 5, 6. Then I have the point 0, -4, so 0, 1, 2, 3, 4. And then I have the point 1, -4, so 1, and then we're going to go down to -4. And I have the point 2, -6, so 1, 2, and then 1, 2, 3, 4, 5, 6. Okay. So the only thing we don't know is we don't know exactly where this center point is, but we know it's going to occur halfway between these two. So there's a couple things we could do. We could go ahead and just guess by rounding your corner here and then keep going. Or if you really wanted to be specific, you would look at what happens at 1/2, and then you would solve for that y value. Okay. Now, in my experience, a lot of students don't like doing that because this means now we're working with fractions, and so that's okay. And so here, unless you are actually asked for that vertex point, we kind of can make our best guess because we're essentially just looking at the shape of what this parabola should be. And now take a look. In the very beginning, we talked about what our equation was telling us about our parabola. And so we talked about that it would be the U shape, and that the negative sign tells us the direction, and it would be downward facing. And if you look at what we end up getting, that's exactly what we thought would happen. Okay, so that's just a quick snapshot in being able to do some graphing with your functions. Now the last thing that we have is we have this application here. And with all of these, what you need to know about them is that you will usually not be given the formula unless it's a very in-depth application. And so here, you have to be able to create the formula that you need to solve your problem. So we have that the cost to rent a moving truck per day is $75.25 plus 65 cents per mile. So what do we know? We know that the total of my rental, so my total money, is going to be equal to the cost per day plus the miles, the cost in miles. So that's essentially what we're looking at. So we need to be able to fill this in with actual values. Okay, so we're told that the cost per day was $75.25. So this right here is going to be $75.25. And we're also told that you're driving 0.65 miles, or plus 0.65 cents per mile. So we have plus 0.65, and this is times your miles. And we need to write a function in terms of x to represent the total cost of renting the moving truck. And then find the cost if you drove that many miles. Okay, so this again is your total. And kind of writing it out as you go is a really good way for you to start setting yourself up. So here we need to write a function in terms of x. So right away that tells you that you have f of x. And then we're talking about 1 day. So we have 75.25 plus the cost of my miles, 0.65, and then times however many miles you drove. So that would be the equation that you needed. Now the second part of the problem tells you that you drove 250 miles. So that 250 miles is what you're going to substitute in here. So this value is going to come right in there, and we're going to solve a new problem. So here we're looking at my function of something is the 75.25 plus 0.65 times my something. And that something is 250. So you could simply pull out your calculator and you're going to do 0.65 times 250 plus 75.25 is going to give you a total cost of $237.75. Okay. Now remember, you always want to round to the nearest cent, and our cents are always given in hundreds. Okay. So that is a quick snapshot into evaluating functions, looking at functions, graphing functions, and solving applications with functions. So again, if you have any questions, please let me know. Otherwise, thanks, and we'll see you next time.